Hey guys, today let's dive into a Houdini anti-gravity liquid motion graphic project. If you are eager to follow along, grab the Lychee model from Polyhaven. The link is in the description. First up, create a GeoNode and name it Flip. Use a file node to import the APX file into the scene. Since the model scale is massive, scale it down to around 1.2 meters. Small scale fluids at the size tend to be stable and looks smooth. Now add a collision source node. As the name suggests, it creates a VDB from the input mesh as a collision object in our flip simulation. A voxel size of 0.02 works well, but finding the right balance is key. Moving on to the animation part, drop a transform node. Connect it to the mesh output from collision source and adjust the pivot point to rotate from center. Utilize $FF syntax on rotation X, Y, and Z axis for procedural animation. Animate the collision VDB by creating a reference copy of the transform node. With presentation and animation done, let's move to creating a particle source for the flip simulation. Drop a scatter node, scatter around 1000 points on the surface, and apply $F as a parameter value for the global seed so that we get random points generated for each frame. On the right side, hold the geo at the first frame using time shift node. Drop another scatter node, scatter around 100 points on the surface, and don't forget to toggle on source prim and source prim UV in the output attribute panel. Now drop an attribute interpolate node and connect the scatter node to its first input and output anim geo node to the second input. The scattered points will now follow the animation properly. Create an attribute randomize node and generate an attribute named emit frame, assigning a random number from 1 to 170 to each point. Now use an attribute fade node. Use the emit frame attribute as a fade start frame and create a new attribute called emit that goes from 0 to 1 and back to 0 in an interval of 40 frames. Now we have our emit attribute. Drop an attribute transfer node and transfer the attribute to our source scattered points. Let's decrease the distance threshold to 0.19. Let's use a blast node to blast away points where the emit attribute value falls below this threshold. Drop an attribute delete node to remove all unwanted attributes and optimize the memory footprint while caching. Always remember to cache out source point and collision VDBs before feeding them into the flip simulation. This helps in flip simulation performance. So now let's drop down a DOPNet, dive inside, and in the pop source node, set the emission type to all geometry and point the SOP to file cache node. That's all we have to do for this node. In the flip object node, set the particle separation to 0.01, grid scale to 1 and viscosity value to 5 in the physical tab. This gives our simulation that small scale tendril look. Now use the pop force node to apply some force in the Y direction. Set it to 1 and add some noise to that force. Now let's drop a pop attract node to add an extra layer of attraction. Set it to 1.5 meters above the surface and force scale to 5. Now let's drop down the flip solver. Everything here is default except in volume motion tab. Set the velocity transfer to APIC. In the viscosity tab, toggle on enable viscosity and solve viscosity with adaptivity, and also enable surface tension with a value of 20 so that the particle attracts each other. Drop down a gravity node and set the force in Y direction to be 6.9 or 7. This force drives the liquid to move upwards. Now it's time to add collision mesh. Drop down a static object node. Reference the SOP path to out anim geo. Since our mesh and collision mesh are animated, remember to toggle on deforming geometry. In the volume tab, set the mode to volume sample and append the out anim BDB node to the proxy volume section. In this way, we have set our collision in this simulation. Merge the static object with the gravity force node. Let's jump back to OBJ SOP label. Let's use the DOP import node to visualize our simulation output. We can choose the flip source preset. In the DOP network field, drag our DOP net, and in the DOP net field, go inside our DOP net. Let's copy our flip object, come back out and paste it in there. Drop down a file cache node to cache out our simulation. So now let's create a particle fluid surface node to move on to meshing our fluid simulation. A general rule of thumb is the particle simulation in this node should be similar to the particle separation that we set inside the DOPNet. Let's dive inside our DOPNet. In the flip object node, right click on the particle separation, copy the parameter, and we need to jump back out, and in particle fluid surface node we need to paste it as a relative reference. In the filtering tab, let's set the dilate to 2. It smooths out the rough surface. Let's add a normal node to get new normals. Smooth out the position and normal using smooth node. Set the smooth strength to 50. So our flip simulation and meshing process are complete. So in order to render this, let's render this scene in Solaris using Karma. So here from the drop-down menu, select Solaris. This will give us a UI optimal for Solaris USD workflow. Drop down a SOP import node and import the liquid mesh from the object label to Solaris. Similarly, import the lychee mesh. Merge these two together. Let's create a material library node and dive in. Create a Karma material builder. Use MTLX image node to import the PBR textures like albedo, roughness, normal, and height field, and connect these nodes to its appropriate section in standard surface. Create another material builder for liquid. In the standard surface node, set the transmission to 1 and dispersion to 3. Now let's drop down and assign material node and just drag the primitive from the scene graph to the primitive path field and the appropriate material to the material path. Now for the lighting, create a dome light node and let's add a SDRI texture that you want to the texture field. Add a camera and place it accordingly. Now let's drop down a Karma node. In resolution mode, set it to manual and set your desired resolution. We can use either XPU or CPU to render this frame. In the rendering tab, toggle on motion blur and set velocity blur. And there you have it, guys. Thank you so much for watching. I hope this walkthrough was helpful. If you would like to check this HEIF file itself, it's on my Patreon for free. Link is in the description. See you guys on the next one.